Hi, let's see this problem. We are given a sorted singly linked list. We need to remove duplicates from it. Let's say we have this linked list. It is a sorted linked list. So all the same items are together and we just need to remove the duplicates and need to have only distinct items in the linked list finally. So if our linked list is 10, 20, 20, 30, 30, 30, then this 20 is a duplicate, this 30 is a duplicate, this 30 is also a duplicate. So our linked list should be modified to 10, 20, 30. Let's see this example. In this example, there are no duplicates. So we need not to make any change in the linked list. If linked list is empty, then also we need to keep it empty and we need to return. Now please pause this video and try to write down a function that takes linked list had as an argument and removes duplicates from this linked list. Let us now talk about idea to solve this problem. Say we have this linked list and we want to remove duplicates from it. So we are going to traverse this linked list using a current reference or pointer. And what are we going to do? We are going to begin from here. And at every point, we are going to check if current's data is same as current's next data. If they are same, then we need to simply remove the next, right? So when you begin from here, this data and this data are not same. So you will not remove this node. You will move current here, right? Now current and current's next data are same. So if they are same, you need to take this node out of this linked list, right? And then you need to change your current to here, right? And once you reach here, again you will compare current with current next data, and this is same. So you need to take out this node from the linked list and you need to change your current here. So that's what we are going to follow. Now please pause this video and try to write down solution yourself. Let us now talk about the implementation of this algorithm. So we have this linked list. We begin a current pointer or reference from the beginning of this linked list, which is head of this linked list. Now we move this current one by one. And when do we stop? We stop when we reach this node because this node has nothing after it, right? So we run a loop that says that you need to stop when current next is null, right? That's the loop condition we have. Now one important thing and one important observation here is when you are checking for current arrow next or current dot next for null, you must ensure that current is also not null. Because if current is null and if you try to access currents next, then you will get null pointer exception in Java and you will get segmentation fault or runtime error in C++. So you need to ensure whenever you access current dot next or current arrow next, you have current as not null. That's why we put this condition. We can put this condition outside this while loop also. For example, we can remove this condition from here and we can add an if condition here. If current is equal to null, then return. And that's also is fine. Let us now talk about the implementation. So in this implementation, we are going to use a reference and pointer that begins from here and goes till this point. We need to stop at this point because there is nothing after this node. And when we are moving this current pointer or reference one by one, we need to check if current's data is same as current's next data, right? If they are same, then we need to remove current next from the middle. That's all we are doing in this implementation. So we run a loop that checks whether current is not null and current arrow next is not null or current dot next is not null. See, whenever you write a loop that checks whether current next is null or not, you need to ensure that current is also not null. That's why we have put this condition before. We could put this condition in a if also, right? We could put an if condition here if current is not equal to null. And then we can remove this from here. That's also fine, right? That's also an option. But we just have to ensure that when we are accessing current dot something or current arrow something, current should not be null. Because if current is null and if you try to access something on this current, you will get null pointer exception in Java and you will get segmentation fault or runtime error in C++. So that's why we have this condition, and then we are having this condition. This condition is required because we want to stop at this node. We don't want to process further, right? So we run a loop that stops at the last node, begins from here, current is beginning from the head and going till the last node. And inside this loop, we are comparing current's data with current's next data. So if we begin from here, they are not same, right? If current data and current next data are not same, then we come into the else part of this code, and in the else part, we are simply moving current to the next, right? So our current simply moves to 20. Now we again compare current and current's next data. So they are same. When current and current's next data are same, you need to remove current's next. Now how do you remove current's next? To remove the current's next, it is super simple in Java. In Java, you need to simply do current.next equal to current.next.next. That's what we have done. So we do current.next equal to current.next.next. We move this pointer from here to here. Right? That's what we do in Java. We simply take this node out of the linked list. Java automatically does garbage collection. So we do not need to worry about freeing memory for this. In C++, we also want to achieve the same thing in C++ as well, but we also want to ensure that this memory is deallocated. Otherwise, there will be memory leak in this program. So how do we deallocate this memory? To deallocate this memory, before we change current.next, current arrow next equal to current arrow next, we need to store current arrow next in a pointer variable. Then we need to delete the memory allocated to that pointer. That's what we have done. So we store current arrow next in a pointer variable. Then we do what we did in Java. These things are same in C++ and Java. Only these lines are extra in C++. So we store current arrow next and then we delete this temp pointer, right? That's how we deallocate the memory and we ensure that there is no memory leak. That's the simple implementation. And once you make this change, what will happen? This node will go out of the linked list and these two will be linked and your current will still be here. We do not change current in this particular if part, right? We keep it here because current might again be same as current arrow next data. It might be 20 here as well. That we'll see in the next example. So after we have done this, we again check current data with current arrow data, current arrow next arrow data or current dot next dot data. They're not same this time. So we are going to fall into the else part and we are going to move current here. Now when we move current here, we again compare current and current next data. They are same. So what are we going to do? We are going to remove this node from here and we are going to link this node with this node. Right? And once you link this node, your current still is here. We do not change current to current.next or current arrow next. And now you will understand why are we not changing. Because now current data is matching with current next data again. So what are we going to do now? We are going to remove the next. We are going to remove this particular node from the linked list. And when you remove it, what are you doing? You're doing current next equal to current next. And current next is null. So your current next will now become null. Right? This will now become null. So we have achieved what we wanted. We have removed all the duplicates and we have appropriately set the next of last as null. And our duplicates are removed. Let's now do one more example to understand this implementation better. We have this linked list. We begin current from here, right? And we run a loop. We stop when current arrow next or current dot next is not null. And what we do inside this loop, we compare current data with current's next data and they are matching. So we are going to fall into this if condition. And when we fall into this if condition, what are we going to do? We are going to link this node with its next. So we are going to change the next link of this with null, right? Null or null. And how do we do this? We do current.next equal to current.next or current arrow next equal to current arrow next. See, these two lines are only to make sure that there is no memory leak. This is the main logic. So after you do this, your current remains here and its next changes to this thing. And if you're programming in C++, then this memory is also deallocated by these two lines. So your linked list is modified, your next is appropriately set, and this implementation works for this as well. Now, one interesting thing in this particular function signature is we are not returning modified head of the linked list because this function is never going to modify the head. If there are duplicates, we remove the next node, not the current node. So head is never going to be changed by this function. That is why we have return type void. We do not need to change head at all.